Morning everyone. So we want to start a class data structures using C++. Okay. So today topic is evol- evolution of arrays. Evolution of arrays. So what are infix, prefix, postfix notations? Okay. So this is the questions. What are the infix, prefix, and postfix notation? What are the infix and prefix and postfix notations? Okay. So we can write. So we can define like this. The way to write arithmetic expression is known as a notation. The way to write arithmetic expressions is known as a notation. Is known as a notation. Okay. So an arithmetic expression can be written in three different three different but equivalent notations. Okay. So first one, infix notation. Second one, prefix notation. Third one, postfix notation. So first one, infix notation. What is infix notation? Infix notation. We write, okay. So when we are going to write this infix notation, we write expression in infix notation. Example, a minus b plus c. A minus b plus c. So a minus b plus c, where operators are used in between operands. Okay. It is easy for us, it is easy for humans to read, write, and speak in infix notation. Okay. But the same does not go well with computing devices. Okay, that is infix notation. Second one is prefix notation. So what is prefix notation? In this notation, operator is prefixed. Operator is prefixed to operands. Okay, that is operator is written ahead of operands. For example, plus AB. Okay, so this is equivalent to its infix notation A plus B. Prefix notation is also known as Polish notation. Okay, so what is prefix means? Before only we are writing a before only if I declare if for a plus b, if I am declaring plus ab, then it becomes a prefix notation. So first operator will come, then operands will come. Okay, so infix notation means in middle operators will come. So a minus b plus c. So what is your operator? Minus and plus are operators, a b c are operands. If operators are present in between operands, then it is called as a infix notation. So if operator is present first, then operands are present, then it is called as a prefix notation. Okay, like that we are having a postfix notation also. Postfix notation. So what is postfix notation? This notation style, this notation style, this notation style is known as reversed Polish notation. Reversed Polish notation. Okay, this notation style is known as reversed Polish notation. In this style, in this notation, in this notation style, in this notation style, okay, so in this notation style, the operator is postfixed to the operands, postfixed to the operands. That is the is written operator is written after the operands of the operands. For example, for example, AB plus, okay, this is equivalent to its infix notation. Infix notation A plus B. A plus B. Okay, so these are the prefix, infix, prefix, and postfix notations. Okay, right. So some examples of infix, prefix, and notations can be defined. So what are the examples you'll see? Infix notation, prefix notation, postfix notation. Infix notation, prefix notation, and postfix notation. So I can take table here. Okay. Okay, so first one in fixed notation, a plus b. A plus b, it can be written as, in prefix we can write as plus ab. Plus ab. In postfix we can write as ab plus. Ab plus. Second one, in second case, if I am using a bracket b, a plus b, this can be represented as okay. So just let me give it. Okay, I can write all these things. Okay, the second one, okay, a plus b can be written as a plus b, a plus b into c. A plus b into c can be written as into plus abc, into plus abc. Ab plus c, ab plus c into. Okay, so this is postfix notation. Now third one, we'll consider third one is a a into b plus c can be written as, first into will come, then a, then plus bc. Okay, this is prefix notation for this. And whereas postfix, first operands will come abc, abc will come first, abc plus asterisk. Okay, that one, third one. Fourth one, for fourth one, first a by b plus c by d, a plus b by c by d. Okay, so this can be written as plus slash AB slash CD. Okay, so in prefix notation, whereas in postfix notation, look at AB slash CD slash plus, AB slash CD slash plus. Okay, this is postfix notation. Similarly, fifth one, we are having A plus B, A plus B asterisk C plus D, C plus D. This can be written as asterisk plus AB plus CD. Okay, whereas in same thing can be written in postfix as AB plus CD plus asterisk. Okay, so this is AB. So this can be done by board mass. Okay, you know board mass. So bracket of addition, subtract, bracket of BODMAS. Okay, BODMAS means bracket of division, multiplication, addition, last is subtraction. Okay, so last one is subtraction. Sixth one, sixth one can be written as A plus B asterisk C close minus D is written. If this is written, how can we write? First minus will come, then asterisk will come, then plus will come, then ABCD will come. This is postfix prefix notation. In postfix notation, first operand should come AB plus C asterisk D minus. Okay, so this can be done like this: AB plus C asterisk D. Okay, okay. So these are the infix notation, prefix notation, and postfix notations. These are the different types of notations we are having. Three types of notations: infix, prefix, and postfix notation. I hope you all have understood this one. Okay. So next topic is application of stack. What application of stack will be? Application of stack. So what are the different types of application of stacks are there? We'll see. Application of stack. First one is expression evolution, expression evolution, expression conversions, expression conversion, like expression conversion from infix to postfix, infix to postfix, infix to postfix, infix to prefix, infix to prefix, postfix to infix, and then last prefix to infix. Third one parsing. Fourth one is simulation of recursion, function call. Okay, so these are all the different types of applications of stack. This is very important. Okay, so in first unit we have seen what are the different topics we have seen. So far we have covered one-dimensional arrays, two-dimensional arrays. First, we have learned about data structure, types of data structures, algorithm, pseudocode, flowchart, and analysis of algorithms. Okay, we have learned about algorithm, pseudocode, flowchart, and analysis of algorithm. Next, we have seen 1D arrays, 2D arrays, and ND arrays, and representations of address calculations. That is order list, string manipulations we have seen. Next, we have seen about the stacks. Okay, so what is a stack and abstract data type? Representation of stack using arrays. Now we have seen prefix, postfix, and postfix notations, and applications of stacks also we have seen. Okay, so these are all the different types of okay, these are the different types of topics covered in first unit. Okay, next we are going to learn about the recursions. What is recursion and why we require a recursion? Okay, so next topic we are going to learn about is queues. Queue. Okay, what is a queue and why we require a queue? Queue is an abstract data type. Abstract data type. Okay, queue is an abstract data type or a linear data structure in which the first element is inserted in which first element is inserted from one end. First element is inserted from one end called rare called rare, and the declaration and the deletion is the deletion of existing deletion of existing element takes place from the other end called as front end, called as front. Okay, so insertion is done at one end and deletion is done at other end. So this is the queue. This makes queue as a FIFO. FIFO means first in first out. FIFO data structure. FIFO data structure. Okay, so which means the element which means that element inserted first will also be removed first. Okay, the element which is inserted first is the first element to remove. Okay, the element which is inserted first is the first element to remove. So what are the basic features of queue are like stack queue is also an order list of elements of similar data type. Okay, what are the basic features means? Let's see. Basic features of queue. Basic features of queue. Like stacks, queue is also an ordered list of elements. Okay, like stack queue is also an order list of elements of similar data types. Okay, like stack queue is also an order list of elements of similar data types. So that is the first point. You can say second point is Q is a FIFO. Q is a FIFO structure. Q is a FIFO structure. And third one is once a new element is inserted into the queue, once a new element inserted into the queue, all the elements inserted before the new element in the queue must be removed. Okay, so to remove the new element, this one. Next peak function. Peak function is oftenly used to return the value of first element without dequeuing in it. Okay, so these are the basic features of queue. Next, applications of queue. Serving request on a single shared resource. Okay, these are the different types of applications we are in. Applications of queue. What are the different types of applications we are having? Applications of queue. First one is serving request on a single shared resource. On a single shared resource like a printer, CPU, task scheduling, etc. In real life, call center phone call center phone system in real life call center phone system will use queues to hold people, calling them in an order. Okay, so in call centers also, in real life, call center phone system will use queues to hold people, calling them in an order. So whoever request first, so their request is served first. So serving a request on a single shared resource like printer, CPU, task scheduling, these all things are considered as a queue. Means whichever comes first, only that has to be requested. Whereas in stack, whichever comes last, that is the first element to remove. But in queues, it is not like that. In queues, whoever comes first is the first element to be removed. Okay, if I place the first element in queue, that is the first element to be removed. Okay, so in queues is different from stacks. Okay, third one, handling handling of interrupts, handling of interrupts in real time, handling of interrupts in real time system. Okay, like the interrupts the interrupts are handled in the same order as they arrive. Okay, first first come first served. Okay, first come first served. So this is a okay, so these are the applications of queue. So we can even have okay, so queue representation, we can draw a queue representation also. Queue representation, how we can define a queue representation? See, so insert shapes. Okay, okay, so this is a queue representation. So if I am writing the first element here, okay, 10. So this is the first element to be removed. Okay, so this end is called as a front end or front end. Okay, so this is the so from rear end I am inserting the element, from front end I am deleting the element. Okay, so I'll show it in a diagram. So there will be two pointers here. So rear pointer, using rear I'm inserting the element, using front I'm deleting the element. Okay, so here I'm having two pointers, front pointer and rear pointer. Okay, there are two pointers. So to insert element, rear pointer will move forward. Okay, so rear will move here. Then I can insert the element 20. Okay, I can insert the element. I can insert the element 20 in it. I can insert the element 20 because pointer has moved here using rear. Okay, so again, if I want to insert one more element, again this rear pointer will move front. Rear pointer will move front. Rear pointer will move front here. I can insert the element 30 in it. 30 in it. Okay, I can insert the element 30 in it. Now, if I want to delete an element, this front pointer will move into this place. Okay, so front pointer will move into the first place. Then what happens if front pointer moves? This element will be deleted. Okay, if front pointer moves, element will be deleted. If rear pointer moves, element is inserted. Okay, if rear pointer moves front, then what happens? Element is inserted into it. After 30 we'll get here 40 element is inserted. If front pointer moves, it will delete an element. Okay, so in this combination, so q will represent, so there will be two pointers, one is front pointer and rear pointer. Where rear pointer inserts an elements, whereas front pointer deletes an elements. Okay, to delete an element we require a front pointer, to insert an element we require a rear pointer. Okay, understood? So this is a q representation. We will stop our class here. We'll continue in next class.